This is first lecture on centroid. It's part 1. It means it's a basic first lecture. Centroid is defined as a geometrical center. Our interest in this lecture is to find geometrical center for areas. For this purpose, we are going to use these two formulas. First formula says xc, that is x coordinate of centroid, and that is equal to sigma xa upon sigma a. Second formula says yc is equal to sigma ya upon sigma a. Yc is y coordinate of the centroid. Now, what exactly this sigma x and sigma y are will be clear as soon as we proceed with actual solving of a problem. Before we actually go to the problem, let's see what is the end objective of our lecture. By end of this lecture, you should develop a capability of solving a typical problem which has just come on the screen. Look at the shaded portion of the figure. You all will agree that this shaded portion has come about if from the square you take out this triangle number 1, then you take out triangle number 2, and you take out quarter circle, which are called 3. If you take these 3 out of this square, you get the shaded figure. And what is expected that you develop a capability to find location of the centroid of such figure. Let's take one more example. Here is a circle from which a square, that is figure number 2, is removed. So these are the type of problems you will typically come across. These two are similar examples. In order to be able to do this, there is some prerequisite required from your previous knowledge, and that prerequisite is for standard figures. Let's say rectangle is a standard figure. You should know the location of the centroid. Now here is a rectangle. I have marked location of the centroid by a red cross. xc, that is location or x coordinate of the centroid, is given by b by 2, and similarly yc, that is y coordinate of the centroid, is given by d by 2. This is elementary, and it is expected that for the standard figures you already know it. Rectangle is one of the standard figure. Another standard figure is circle, where I have marked with red cross the centroid. xc, you will agree, will be equal to radius of the circle r, and yc is 0 because the centroid is on the x-axis. Another standard figure is quarter circle, where the marked centroid has x coordinate as 4r by 3 pi and also y coordinate as 4r by 3 pi. Triangle, the similar numbers are x coordinate is b by 3 and y coordinate is d by 3. And for semicircle, x coordinate is actually only the radius, but y coordinate is 4 by 3. Along with these standard figures, you need to add just one more figure, and that is sector of a circle or part of a circle whose half angle is alpha. Location is marked with a red cross, and x coordinate, that is x coordinate, that is distance from y axis of this centroid, is given by 2r sine alpha upon 3 alpha. yc here is 0 because x axis passes through the centroid. These formulas or these results can easily be derived. But what is expected is you have done this before And using these results, we are expected to combine these standard figures and solve problem on an area which is combination of this. So best way to tackle is if I take a example and take you through the process of solving. Let this be x and y axis, and let there be a square 10 by 10, and to this add another square 5 by 5, and then I add a quarter circle, and then I add a triangle, and then I add one more triangle, and then one more triangle at the bottom, and one more semicircle. And then through this planar figure, let's say I drill a hole of radius 2, and I pose a problem that I want to find out centroid of this combined figure. So method I recommend is you make a column, you make a table whose first row looks like this: number, area, x coordinate, y coordinate, ax and ay. Now let's take the first area, say the square. You all know the location of the centroid will be here, and x coordinate is this distance and y coordinate is this distance. So once we have this information, we put it in the first row of the column under the head row. Figure number 1, area we write as 10 by 10. X and y we write as 5 because these are the coordinates of the centroid of this square. Ax and ay are simply multiplication of a into x and a into y. In this manner, we go to figure number 2 and fill up the next row. Here, centroid is located here. X distance, mind you, is from y-axis. So it is what arrow shows, and y distance is distance of that point, centroid point, from x-axis. We put this information in next row. Area 25, yes, because 5 into 5. X 12.5 because it's 10 plus 2.5. And y is 2.5. What is 2.5? Half of 5. Again, ax and ay have come out of multiplication. Look at area number 3, which is a quarter circle. Centroid location here. X coordinate is this and y coordinate is this. Now area of a quarter circle is very simple to find. If area of circle is pi r square, quarter circle is pi r square by 4. Now if you remember, the location of the centroid from the formula shown in earlier slide is given by 4r by 3 pi. Here the radius is 5, and therefore we work out this number 4r by 3 pi, which if you do actually on the calculator, it will come to 2.12. So therefore x in this case becomes 2.12 plus 10, that is 12.12, and y becomes 2.12 plus 5, that is 7.12. Having finished these three figures, we go to figure number 4, a triangle whose centroid is located here, and this is x coordinate and this is y coordinate. For triangle, you remember that it's b by 3 and d by 3, and therefore for triangle the area simple 10 into 5 by 2, x coordinate 5 by 3, that is 1.67, and y coordinate 10 by 3, that is 3.33. Why minus sign for 1.67? Because if you come back to the triangle and see again the location of centroid, it is on the negative side of x-axis, so we just put minus. Obviously ax is going to be minus, so that's fine. Similarly, We do our operation for figure 5. We locate x and y. We locate centroid, its coordinates, and put them here. These numbers are 12.5 minus 1.67 minus 1.67. Same operation for figure number 6. And that is, here is a centroid, here is x coordinate, here is y coordinate. We look at it and fill up the row. Area 10 into 5 by 2, 25. X coordinate 10 by 3, 3.33 positive this time. And y coordinate negative, because it's below x axis and it's 5 by 3, that is minus 1.67. Now come to area 7, semicircle. Look at the centroid. See, this is x coordinate, see, this is y coordinate. Put in the numbers. Area pi r square by 2, that will come to 39.25. X is 5, the radius, and y 12.12, and you have ax and ay. Now from all this we are going to take out, we are going to puncture a hole, that is take out this circle. So we treat it exactly in the same manner, even the area which is taken out, except that we put negative sign for the area because it's taken out. So area of the circle is pi r square, so that will be 12.56 minus, because it's taken out. And you will note that x and y is 0 because the centroid is absolutely at the origin. And naturally ax and ay are going to be 0 for this. Now if you remember the formula, x is given by sigma ax by sigma a, y is given by sigma ay by sigma a, and all you have to do, the whole idea of making the table was to it was for the suitability of the addition. So when we say it is sigma a, what we are going to do is we are going to take all this and add up. You have your sigma a out here. Then for sigma x, take all this, including the first one, add up, you get sigma ax, and similarly you get sigma ay. Plug it in here and you will get your answers as x is 5.42 and y is 5.13. This is the location. See here the bold red mark, approximately, but that is the location of this entire centroid, and that is it. You can follow this process and literally solve any problem on area. Thank you.